Hello! In this video tutorial I'm going to describe Torino, which is one of my personal projects in GitHub. It is released with the MIT license, so it can be used by anybody. And I want to do this both to showcase Torino and also my web framework, because it consists of a backend API implemented with my framework named BlackSheep and a front-end layer built using React and TypeScript. Now, in this video, I'm going to explain several things. If you don't know everything about how to create Python virtual environments or about Azure, don't worry, because I will create more tutorials about these topics. But for now, I want to show you the project, which is under my GitHub organization called Neoteroi. And I'm going to show how to create a development environment and start the application using an Azure storage account. So what is this? It is like a private file explorer for Azure Storage account, supporting also photo gallery, resizing of pictures. So when you upload JPEGs, for example, it generates thumbnails and medium-sized pictures for you to be kept together with the original size pictures. But let me show how in practice can be cloned and used. First, just let me tell you that you could also use it with a Docker image I prepared, and it is automatically built and published by a GitHub workflow I prepared in the project. So you could try it this way if you wish, but this tutorial is about also how to prepare a development environment for the solution. So I will clone it. I assume that you have Git installed following this tutorial and a modern version of Python, but let me go through it later. I will first clone the project in a folder, any folder you wish. It will be fine. Now I just cloned the repository. I will go to its folder. And now the folder structure contains a server and UI, because I like to separate the front-end code from the back-end code. The server one contains the definition of the API, and the UI contains the single-page application I mentioned earlier. So let's start with the server. I will cd into the server folder and start by creating a Python virtual environment using the env module. So Python, I will use Python 3.10. Now I create a virtual environment. I activate the virtual environment. And now there is a requirement files which I need to use to install dependencies. Now to install dependencies, you will probably need additional packages on your computer. For example, libraries to compile C libraries, and libraries for Pillow, which is the one used to resize pictures. It depends really on whether you're using Windows or Linux, so right now I'm not going to list them, but the Docker file which is available on the project contains also definition of packages that are required to install the server, the virtual environment on a Linux machine. Installing the requirements will take a few seconds, because there are quite a few of them. The project supports different scenarios. For example, it supports PostgreSQL as a backend, as a database to store the virtual file system. It supports SQLite, but also can fall back to Azure Storage Account Table API, which is NoSQL. It's a lexicographically based DB, which is very fast, very inexpensive, but also it doesn't support all the features that you have available in SQL. For example, you don't have count, you don't have join, but it's convenient to showcase the Torino. And what I'm going to do now is configure a storage account for the local environment, start the API, then start the front end and show you how it looks. So now that I installed the dependencies, I would be able to start the server. Well, let me show the project also in a Visual Studio Code. You can create a workspace file which is included in the repository. And you can see that at the root of the workspace you have 3 folders. One for GitHub, which contains the GitHub workflows definitions. One is the infrastructure folder, which contains bicep template, describing the services which are needed if you want to create a full instance of the service in Azure. So this includes, for example, a Postgres database. It includes also a script to create the app registrations in Azure Active Directory, but since these topics are quite advanced compared to the things I want to show now, let's keep them for later. The server directory contains the definition of the API, and you have a server.py file, which if it is started directly from Python, it will import UVcorn, which is a HTTP server for ASGI, and it will start the server on port 44777. Otherwise, of course, you can run it using UVcorn CLI as written here. This code is also important when you want to debug the server, because I have a launch configuration for the Python server file. So if I run it here, I will debug the request handlers, which is convenient when you need to investigate why something is not working as you expected. But for now, let's go to the CLI and just start it this way. It won't work. It won't work because I didn't configure a storage account, and it throws exception, that configuration error, missing setting storage account name. So let's configure it. First, let me tell you how the configuration looks like. I published a library in PyPy, which is called Essentials Configuration, which lets you define different layers of configuration. So, for example, you can configure settings YAML files, and where you have defined some application settings. And then you can override these application settings using environmental variables. Now, for simplicity, I will use an existing storage account that I created for this demo and configure storage account name and key. So I go to my Azure portal subscription, my subscription on the Azure portal, and you can see I created a Torino demo storage account resource. I will copy name and key to the settings of the application, so that you can we can start the application and show how it works. I'm going to record the keys of my storage account, because anyway I will rotate the keys or delete the storage account before publishing this video, so it's no issue. Access keys, you can see here. You could use an emulator and start the storage account locally, but I prefer to use a real storage account when developing applications. It has some benefits. For example, if you were developing an API using Azure Search to index files in a blob, then it would be much more convenient to use a real instance of a storage account rather than an emulated one. So now that I configure storage account name and key, I can start the server and it should work. Okay, so it started. I can open it in Opera. And you will see that at the root of the API, it doesn't serve anything, so it returns not found, which is fine. but it publishes Swagger documentation, so OpenAPI documentation under the docs path. And this documentation is automatically generated by BlackSheep, which is the web framework used for this solution. And it's quite convenient because the framework knows the list of request handlers defined at different routes. And if you annotate them using Python typing, it knows also what kind of response it will return, and it generates automatically for you the examples of the response. The same applies to input values. Now, the API like this can be already used to create nodes, create the albums in the storage account table API, but it's not so interesting. It's better to, in this case, it's better to start the UI part so that you can also see it more comfortably. So I will open a new terminal, go to the same folder, which I need to double check because I don't want to do mistakes. Project temp Torino. I go to the UI folder. The UI folder contains the single page application, and this one was bootstrapped using the Create React app, and it is using Yarn. So if you don't have Yarn installed, you will need to install it globally using npm, and once it is installed, you can install dependencies using Yarn install. Fortunately, I have very fast internet connection alone. Actually, I think it's very fast. Of course, there are people who will have it even better than mine, but I don't complain. And once the packages will be installed, we can use yarn start to start the Webpack development server for the single page application part. But before doing so, let me also open the workspace, which is available here. So code project workspace. So I have two instances of Visual Studio Code open, one for the server part, one for the API part. This is important because the API by default, when you run it locally, starts on port 44777, but the single page application doesn't make assumption about where the API resides and support different places, because you could deploy the single page application on a, for example, on a Azure storage account with having static websites enabled, while having the API somewhere else. So what you need to do to start it locally for development is to modify the settings.js file to say that API URL is http localhost 44777. Now, if I go back to my terminal where I installed the dependencies, I can do yarn start, and everything should work. The first run takes some seconds. If some error will happen, we will debug together and find out the solution. Sometimes Webpack is quite slow to start the first time development server. Yeah, here it's saying that I'm using a TypeScript version for S-Lint, which is not supported because it's too recent. But you see now the application started. On the left, you have the main menu. This application is using Material UI for React. And you can see you have albums, account, and about. If I go to about, it will show the system version, the link to the repository in GitHub, and the link to the OpenAPI documentation of the API. And it is informing that the system is not configured to use OAuth applications. It is therefore running without authentication. I will show in a second video that we can enable authentication, and the system will work automatically asking for interactive sign-in on the front-end layer, and it will enforce authorization and authentication on the API layer. But I will explain this later. Now I just want to show the basic information about the system. So if I go to albums, here I will see a list of albums. Each album can have a different cover assigned, but this is not implemented yet. It is just designed to support this scenario. Currently, always this picture that I drew a long time ago is used for albums, but I can also create new ones. If I click enter, it will submit the creation. And right now, I configure the system to use a storage account, so it is creating this information in the table API of the storage account. Then I can go inside the system, and I can start creating folders. I can go into subfolders and create subfolders, and so on. Of course, everything happens dynamically, so even when I refresh the page, the front-end is going to fetch the information from the API that is necessary to display this path and the contents of the folder. I can also upload files, of course, otherwise it wouldn't be so interesting. So let me show how to upload pictures, for example, to the demo folder. I can either select the files or use drag and drop. And right now, the browser still reminds the last folder that I was using, which is the wallpapers folder. I will select several images, and you can see they have different weights. They go from 2 megabytes to 400 kilobytes about. Here you can see a preview, which is obtained using HTML5 canvas, meaning that when you see this preview, everything is happening on the browser, on the client side, and also summary of the size of the file. You can remove some of them if you wish, and you can upload. When I upload, what happens? The frontend will contact the API to ask for shared access signatures of the storage account to upload the files, and then the upload part happens on the front end. So in the source code is written in TypeScript. It is chunking the files. It supports files of any size, potentially, right? Any size supported by storage account, and it is uploading chunk by chunk. Once uploaded, since we are speaking about JPEGs, the API will also create different size of pictures, thumbnails and medium-sized pictures, as I said at the beginning. And at the moment, everything is happening inside the API because I only configure the storage account. But in the future, it will be possible to configure an Azure function to do the same in another service. And by default, you can see that I have a table of objects. I can download the original objects clicking on the name of the file. And I can display gallery view. When I click on a picture, a photo gallery will open. This is using the fantastic library PhotoSwipe, which is also open source. And I can scroll the pictures using my mouse wheel or other keys like A, D to scroll right and left. It also works with swipes on mobile devices, of course. I can rename the files by all the folders by double clicking on them. So let me show you. Update it. I can also select files and copy or cut them. So if I cut these files, I can move them to this other folder. I can copy the links and paste them to other folders. So in this case, both nodes of the virtual file system points to the same file. And what happens when I'm reading this information is that the front end is asking for a shared access signature to have read access over the blob. The files are downloaded directly from the storage account. This is important because it would be a waste of money to delegate the part of fetching the bytes arrays of these objects from the blob storage to the API, and because it would have much more network traffic, so it would be much more expensive. In this case, the frontend is asking for a shared access signature with read access, as I said, and downloading the files directly from the storage account. Now, I know that for many these topics will look too advanced. I mean, many of those who want to see this video to have a grasp on what can be done with the BlackSheep, but no worries, because I will explain more in different videos. So the system is still a work in progress, so it's not completed by any means, but it already provides several features, as I'm showing. So the virtual file system, ability to upload the pictures which are resized, ability to upload videos, because you can upload videos of any size. You can upload music, and then you have HTML controls to play the MP3s, for example, or other formats. So it is a work in progress, but I think it is already worth checking out. What also I will be showing in a different video is that you can configure a PostgreSQL database running locally, for example using Docker, and configure a SQL connection string to the PostgreSQL, and use this one to store information about the virtual file system instead of the storage account table API. This is achieved using dependency injection. I'm a great fan of dependency injection. I think it provides clean architecture. It helps providing clean architecture, and it gives, for example, in this case, the ability to switch between different implementations of SQL, because you can use SQLite or PostgreSQL, and also completely different implementation of data access layer. How this is achieved is that we have a domain namespace which is abstracted from the frontend and the back and the data access layer. So the domain layer is like business logic, which defines, for example, for albums, it defines an abstract class, which is albums data provider. This abstract class defines the methods which are needed to implement a concrete persistence layer for the system, for the API. And then the data folder, data package, contains different implementations of these persistence layers. One for SQL, which is using SQL Alchemy, so it works both with Postgres and SQLite, and one for the Azure storage. These are then configured in services, so they are injected as services when request handlers are starting, or when the web application is starting, depending on their on whether they should be singleton for the whole application or transient services, so services created every time they are needed, or even scoped services, so services which are instantiated at every web request. And thank you for listening. So this was a preview of how you can start Torino locally. It was also touching the information, giving some information about BlackSheep, and touching some topics regarding the web framework. I will go into more details about the web framework in following videos. Thank you.